Hello and welcome to the lecture series on blockchain technology. The goal of this series of lecture is to explain in growing detail and depth the technologies behind blockchain. I will mostly use the Bitcoin blockchain as an example, but later in the series we will also look at other implementations of blockchains. This first week, which is sort of an experiment, we will look at the different building blocks of the blockchain. Each will be described in some detail. This first lecture of week 1 is a general overview and introduction. In the second lecture we will look at the construct of the blockchain itself. Next we will investigate the network used for blockchain technologies. Possibly the most important part of blockchain technologies is the consensus model. Because blockchain seems to have solved an old problem in computer science of how to get a system to reach consensus when parts of the system are either failing or untrustworthy. We will briefly look at the concept of hashing, which plays an important part in the chaining of the blocks and the immutability properties of the blockchain. What is this blockchain? As you can read here in the Wikipedia definition, it is a construct that is a constantly growing list of data records maintained by nodes in a network, and cryptography is involved to secure it. Some of the more important characteristics are highlighted. These can be summarized as append only, so the past cannot be changed. This is sometimes called the immutable property of the blockchain. Distributed. This defines the type of network. This incorporates some of the properties of other peer-to-peer networks like torrent. There is no trusted third party. This is very important. There is no central organization running the blockchain or having control. The control of the chain is also distributed, not just the network. Consensus in the network is needed because there is no boss. This is a very difficult and old problem, especially if one cannot trust all players or nodes in the network. Most of the mechanisms involved in the above characteristics of the blockchain are implemented by or protected by strong cryptographic functions. Most of the points on this slide will be topics in future lectures in increasing detail. We construct the blockchain from blocks of a maximum size. When the block is full, we go to the next blocks. And the next block. Normally, we would include pointers from block to block to construct a linked list or chain of blocks. Like this. And what is special in blockchain is that the pointer actually includes a hash of part of the previous block. This is called a hash pointer. This is represented by this H with brackets. In the second lecture in this week's series, we will look at the consequences of this. The network used in blockchain technology is the distributed network. This is fault tolerant and enables free joining and leaving of nodes. Shown here are some typical topologies of networks. In the centralized network, there is one special node. If that node fails, the network cannot communicate. In the decentralized network, this special function is spread over multiple nodes, indicated by these circles. However, if one of those fails, it has consequences for part of the network. When that one node fails, the nodes connected to it cannot communicate with the remainder of the network and vice versa. It's like these nodes become isolated. In the distributed network there are no special nodes. If one fails, the other nodes can still communicate to the others. It might just take more hops. So if, for example, this node fails, there will still be paths for the other nodes to communicate with each other. It will just take more hops. As you can see, the nodes will find an alternate route to communicate. As there is no special node or boss to determine what each block will look like, a consensus model is needed. We will look at the steps involved here in general terms. More detail will be presented in another lecture. Let's assume there is a mechanism to get data or transactions into the network starting from some node or nodes. All nodes are constantly building what they see as the next block with the data they have. Some random node is selected in each round to present its block as the next one in the chain. This is done by sending to its neighbor, who send it on, etc. All nodes check this block to see if it's valid according to what they know. This is both according to the rules they have and the history in the chain. If a node agrees that this is a valid block, it signifies this by starting to build its next block on top of this one. And the process continues at step 2, while step 1 continues all the time to input new data into the network. Part of the rules is that the longest continuous chain of blocks is called the consensus chain and represents the single source of truth. Hashing is a way to create a digest of something. This can be a message, a string of characters like a name, or any length bit string. This digest is always of a fixed, known length. If this is the input space of the hash, it will map any point in this space to a much smaller space. For example, this point in the input space is mapped to a point in the output space. We will look at hashes in more detail in the last lecture of this week. As an example of a simple hash, think of the hash that takes your name and maps this to the first letter of your name. This concludes the very first video in this lecture series. I hope you enjoyed it. The next video will go into how the blocks in the chain form the blockchain. For questions or suggestions, please contact me on the email address shown. Thank you.